Welcome to the debate. Our focus today is, well, it's on the very definition of information. It's a foundational conflict, really, shaping how we build communication systems and even how we think about knowledge itself. We're basically looking at the mathematical precision view versus the subjective cognitive science perspective.
Absolutely, it's fundamental. I mean, if we can't even agree on what information is, building a science around it becomes tricky. The core tension seems to be, are we talking about, say, a wire's capacity to carry signals? Or are we more interested in what happens in a person's head when they actually get that signal?
Precisely. So our central question today is this. Should the fundamental concept of information prioritize objective, quantifiable measures, the kind rooted in statistics and communication engineering? Or should it prioritize the subjective, context-dependent cognitive transformation, human intention? My position is that for scientific and engineering use, information really must be treated as an objective, measurable thing. It's like the knowledge existing outside any single mind, what Karl Popper called World 3.
And I'll be arguing that the rigor of that objective framework, while yeah, it's powerful for designing systems, it just sidesteps the main purpose of information science. For me, the real value, the essence of information, lies in its effect on the human recipient. So we need a definition that centers on subjective knowledge states, on desired outcomes. That's Popper's World 2. Our field has to prioritize how the recipient's knowledge states is actually transformed.
Okay, let's unpack that objective framework a bit. Information finds, I think, its most rigorous definition in mathematical theory, really pioneered by Claude Shannon. He defined information not by its meaning, which is key, but by how much uncertainty it reduces. It's measured objectively, think choice or uncertainty, and it's proportional to the logarithm of the number of possibilities.
But isn't that where the problem starts? That measure, Shannon's entropy formula, it completely abstracts away meaning. I mean, under that definition, a random string of noise and, say, a beautiful poem could have the same information content if their stats match up. There's no difference.
Well, yes, but that abstraction is precisely its strength. It's genius, really. It makes the quantification universal. It lets engineers define hard parameters like time, bandwidth, system efficiency, completely regardless of the message content. We're measuring the container, not the liquid inside.
But surely the goal of information science isn't just measuring the container. We care about whether the liquid is useful, right? Nourishing, as you might say.
My point is that this objective definition grounds the concept in physical reality. Think about Norbert Wiener's link between information and negative entropy, or negentropy. Information is, in a way, the inverse of physical disorder. The more ordered, the more improbable a state, the more information it holds. This anchors the concept in the objective laws of statistical mechanics. It gives us a universal foundation for communication and control.
Okay, I see the power in that negentropy idea, this notion that getting information is like fighting thermodynamic disorder, Maxwell's demons, sorting gas particles, that sort of thing. But that only really defines the potential for information transmission within a physical system, doesn't it?
Well, for information science to move beyond just philosophy to get real scientific rigor, I believe we have to focus on Popper's World 3. That's the objective knowledge embodied in artifacts, documents, languages, databases. We should be aiming for an epistemology without a knowing subject, as Popper put it. This objective view lets us assess system efficiency reliably. For example, calculating the maximum channel capacity for a noisy system that depends on measurable physical things, power, noise, bandwidth. How can you build a predictable, reliable system without that objective, measurable base?
I understand why you emphasize that engineering rigor. And yes, it's absolutely critical for designing communication systems. But information science isn't quite the same as communication engineering. Our focus is, or should be, on human problem solving. So my position is that the definition of information must satisfy a dual requirement. It has to come from a transformation in the generator's knowledge structure. And critically, it must result in a transformation in the recipient's state of knowledge, what we often call K of S.
But that dual requirement, it seems to me, introduces inherent uncertainty you just can't manage. If the outcome depends entirely on the messy, unique state of each recipient's mind, well, how can you ever establish general laws?
But it introduces necessary reality. We focus on what's called desired information. Information science is fundamentally purposeful. It's about solving problems, achieving goals, resolving ambiguities, whether those goals are factual, emotional, cultural, whatever. Until a sign, a text, a data stream is actually perceived, processed, and transforms that human recipient's subjective knowledge state, that instant of World II transformation, it's just potential information. It's just data, signs on a page.
So, wait, are you essentially defining information only by its successful cognitive effect? Does that mean if I read a dense scientific paper and learn absolutely nothing new, that paper contains zero information, even if it had thousands of bits, according to Shannon?
For you, at that specific moment, yes. The transfer of real functional information didn't happen. The cognitive viewpoint understands that information processing is mediated by these incredibly complex knowledge structures we all have, our categories, concepts, personal experiences. They filter and contextualize every single message, and these structures vary wildly from person to person. So a purely objective, meaning-neutral measure, it's just fundamentally insufficient to gauge the utility of information in this very real, highly contextualized world.
Let's tackle that exclusion of meaning directly. You see it as a weakness. I argue it's the key to universality. We defend abstracting meaning as a necessary step for precision. We're not denying meaning exists, obviously, but we abstract it to find general, reliable laws.
But in doing so, you end up measuring something potentially useful for physics, maybe, but often quite irrelevant to human knowledge seeking.
Not irrelevant, just applicable at a different level. Look, we can even approximate the statistical structure of language itself, forgetting meaning for a moment, using tools like Markov processes or n-gram approximations of English. This shows that statistical approaches can successfully establish general laws of structure, laws that older deterministic models, like Newtonian ones, could never capture. We're defining the boundaries of what's possible in communication.
Defining the bounds of the possible transmission system, yes, I grant you that. But that statistical focus, it fundamentally limits the relevance of your measurement in human problem-solving contexts. Especially, I think, in information retrieval, or IR. Traditional IR research, often guided by the subjective framework you champion, it tends to focus only on the document, the system object, and relies on what's called generator aboutness.
Okay. Meaning what the author or the indexer decided the document is about?
Exactly. That approach just assumes the structure the generator provides is good enough for the user. It completely fails to account for user aboutness and the, frankly, ill-defined problem space that kicks off genuine information seeking in the first place. When you ignore that initial intentionality, the desired transformation the user is seeking, your metrics end up measuring system throughput, capacity, things like that, not actual human utility or knowledge gain.
I'd argue, though, that the physical reality of objective knowledge artifacts are World III entities like libraries, archives, databases. They demand objective metrics. These things have measurable extent, volume, structure. Why shouldn't the analytical and quantitative tools we apply to physical things be applicable to these objective knowledge systems?
Because the knowledge artifact itself only carries potential information. The crucial transaction, the thing that matters for information science, happens in World II, the mental space. So I really challenge the assumption that the quantitative methods designed for physical phenomena, for World I, are automatically appropriate for the mental spaces of World II.
But if information truly is the inverse of entropy, as Wiener demonstrated, shouldn't that relationship hold universally? I mean, if we can apply statistical models to the organization of brain waves, which suggests a physical information processing system right there in our heads, why can't we apply similar models to the outcome of that processing, the knowledge itself?
Because the cognitive space, the arena of knowledge transformation, and physical space just aren't identical. Cognitive states are multidimensional, they're unique to individuals, they're constantly evolving. Trying to objectively quantify these subjective phenomena inevitably leads to inherent irreducible uncertainty. We can't get an exact idea of several individual knowledge states at once, nor can we perfectly predict the cognitive effect of a single document on a single person. Trying to force World 2 phenomena into a World 1 measurement framework, it's an act of reductionism. You end up sacrificing relevance for mathematical neatness.
That uncertainty you describe is precisely why we rely on statistical averages. Okay, yes, individual exact prediction is incredibly difficult. We're not trying to be mind readers here, but the goal is statistical predictability in communication and control systems.
Tell me more about how that predictability works in practice.
Well, we use concepts like ergodic ensembles. The idea is that the time average behavior of a single element over a long period is equivalent to the average behavior of the whole group at one specific moment. Think about traffic flow. Well, we can't predict precisely which car will turn where or if one might crash, but we can predict the average flow, the system's reliability over time with pretty high accuracy. This lets us build systems that work reliably despite all those individual fluctuations.
But that statistical smoothing, it just obscures the fundamental, critical unpredictability of the individual recipient's knowledge state. For the information scientist focused on human utility, that unpredictability isn't just noise to be averaged out, it's the very signal we need to understand and address. This gets to the uncertainty principle of human information seeking.
Okay, explain that principle. What do you mean by that?
It revolves around the concept of the anomalous state of knowledge, often called ASK. When a user starts a search, their need is usually ill-defined. They know they have a gap, an anomaly in their knowledge, but they often can't articulate precisely what information will fill that gap. So they attempt to translate this complex, fuzzy internal need, let's call it a Q2 representation, into a concrete search query, a Q4 statement.
Right, so the query they type in is just an imperfect proxy for what they really need to know?
Exactly that. We sometimes call it the label effect. The user sticks a simple label, the Q4 query, on a much more complex, evolving internal state, the ASK. Now, a mathematical model focused only on efficiently matching that Q4 label to documents in World 3 completely misses the profound difficulty the user is experiencing in their underlying knowledge state. Optimal functioning in information retrieval, from my perspective, has to support the user's intelligence, help them navigate that subjective difficulty. And a purely objective, meaning-neutral capacity metric simply cannot do that.
I certainly concede that mathematical measures don't capture the internal complexity of the ASK. However, I'd argue that without the objective mathematical frameworks rooted in statistical regularity, like defining channel capacity and entropy H and C, we could never have built the robust communication infrastructure that even allows someone to attempt to address their ASK. These frameworks are essential. They provide a universal, reliable foundation for all communication and control systems, whether we're talking about machines or biological organisms. They define the absolute limits of what's possible in communication.
And I maintain that for information science to truly fulfill its purpose, the functional definition has to come back to the user. We must recognize that real information transfer involves an inherently subjective World 2 transformation of knowledge, KS, occurring within a dynamic problem space. And this process fundamentally resists being boiled down to purely physical World 1 quantification. Our mission, as I see it, is to facilitate that cognitive transformation, not merely to maximize how many meaning-neutral bits we can push reliably down a channel.
So, the material we've discussed today really highlights an essential, maybe unavoidable tension between the rigor and universality of the mathematical physical view championed by figures like Wiener and Shannon, focusing on efficiency, objective artifacts, system capacity,
And the inescapable complexity, the utility-driven subjectivity of human communication and cognition, which focuses on the user's transformation, their intention, and resolving that tricky anomalous state of knowledge.
Ultimately, the question seems to remain, should the foundation of information rest on what we can rigorously measure and control in the system, or on what we are ultimately trying to achieve within the human mind?
And where you decide to place that foundation likely determines whether you see yourself primarily as an engineer of the signal, or perhaps as a facilitator of human knowledge.